Welcome back to another exciting video. Let's get started. Algebra 2.1. I hope you're doing well. Here's the lesson for today, absolute value equations and inequalities. So we're going to do tons of absolute value stuff. I hope you remember. We're going to go through Belloc first. We're then going to do the homework quiz. So if you have yet to do the homework quiz, I'm going to pause the video and kind of explain certain things and what I'm expecting there. And then we're going to go through the objective and essential question. So you should be getting your notes out. So you can also write down the bell work. We're going to go through the lesson for 4. That's our 4th thing that we're going to do. Just go through the lesson. It's about the same as yesterday's lesson, to solve linear equations and inequalities. And then we're going to go through the summary and the homework. So let's get started. I hope it will be an amazing time. So here's the bell work. Sorry about the resolution on that. I'm not going to change it, but whatever. These are questions taken directly from your homework. So answer the following questions. Solve linear equations and inequalities. This was the homework that you guys should have completed before coming to this video. So if you have yet to complete this homework before going to this video, you technically can, but you're going to get confused. So try not to do that. Go back, complete this homework assignment on Math Excel, and then you'll see similar questions like this on your homework. Again, Math Excel is a powerful tool. It helps you with view an example, helps you with help me solve this, helps you basically with videos, and it's just a really great tool. So I'm going to show you that, and then we're going to go through those bell work questions. All right, so this is the homework that you should have completed, the solve linear equations and inequalities. If you have yet to complete that, again, go and do that. Access denied. What the junk? Oh, I know why it's access denied. I need to log in again. That's okay. Fast forward through all this. I'm not going to edit it. It's too much time. Too much time to edit it. I'm not awesome like Power. Power edits all his videos. I'm not about that life. All right, let's go back. I really do want to show you. I know I showed you on a previous video before, so if you already kind of know Math Excel and everything, these are really for the straggler kids that maybe had or newer kids that came into my class. This is what you'll see when you go to your actual assignment. You'll see something like this. Click on the video lecture. This is another awesome person, another math teacher, just basically teaching the exact same thing I did. You don't have to watch the video. You can just exit out, but it would be nice to watch the video. Then you can click on any of these questions here. Actually show you different kinds of questions. So you'll maybe get this question, and of course we can solve this. So if I can solve it real quick, this is 5y and then equals 11y. I add the 2 over, so this is 48. I minus that over, so this is negative 6y equals 48. I divide, so that means this is negative 8. And if I actually type in negative 8 here, my answer, I should get that. Okay, and then you can go to the next question. Isn't that great? So if let's just say you don't know this question, you can go to the assigned media again. There's a video lecture just in case. You can also have the video right there. I'll pull it up for you if you want that as well. It'll actually go through the video. It's great. It's basically a similar video. It's awesome. So you can definitely do that. I have videos on Google Classroom if you like. You can also go to view an example and go down all of these. It takes basically you through the steps, but a different example. Most students like this avenue the best, just saying. They like view an example. It helps them out a lot. Okay? Or if you want, you can go to the textbook or this, Ask Instructor. If you click this, it'll give me a direct link to this question, the exact same question. I can do a quick video on how to solve it. I can send it your way, and boom, you can get the right answer every single time. I don't always do that, but sometimes I do. So again, go through that homework assignment. Make sure you complete it as much as possible. It's okay if you don't complete all of it at 100%. Remember, I'm not grading the individual homework assignments. Okay, if you're on Math Excel and have yet to complete this assignment on Google Classroom, please do that. That's due by August 7th by 4 p.m. Remember, this Math Excel orientation is also due on Math Excel by August 7th by 4 p.m. This is your username. I would like your username. This is on Google Classroom. Make sure you do that. Okay. If you have yet to complete your pretest, make sure you do that. Again, you should have completed this already, and you should have completed the homework quiz already before getting into this video. Just saying. You should be right here. This is the assignment that you should see, and you should start completing that assignment after this video. So let's get started. I don't want to waste any more time. Pause this video real quick, get those down, and then we'll get started. All right. So looks like a rather complicated example. It's really not, but the first thing you need to do is distribute. The innermost parentheses need to be distributed first. So I see this first. I'm not going to distribute this yet, but I see this first. I'm going to distribute. This is not in brackets, so I can distribute that right away, and I can distribute those. Okay, so what will this look like? I'm going to write down 32 because that hasn't been touched. Brackets haven't been touched. Plus 9y. And then this is minus 4y, and then minus 8. Notice how that's gone with the parentheses. So that's perfect. Equals. This is negative not 4. Negative 4 times 4y is going to be negative 16y. And then plus, this is 28. Minus brackets. The 5 times the y is 5y. 5 times negative 1 is minus 5. This is minus 12y plus 17, and then brackets. Hope you guys can see that. I'll try to make it a little bit bigger as we're going down. All right, 32 is just going to chill here. I'm not going to do much with that. I'm going to start simplifying inside the brackets. So notice I can simplify this, and I can simplify these because those are constants. So that will become 5y. 4 minus 8 is just negative 4, and then brackets equals. Negative 16y just gets transferred down. The plus 28 gets transferred down. The minus, and then brackets. All right, we're going to town here. So again, the 5y and the negative 12y can be combined. So that is negative 7y. And then I can combine this negative 5 with the 17. And now it'll actually become plus 12. Those are constants. I can do that. Now, and only now, I can look at these negatives. Remember, these are technically understood ones here. So now I can look at those negatives and actually distribute through. And that's exactly what I'm going to do. I'm just changing the sign, really, of these. So 32, 32, just chilling. So this is negative 5y now. And then this will become positive 4. Negative times a negative gives me a positive. Negative times a positive gives me a negative. And since it's 1, I'm just keeping the exact same number of values. So this is negative 16y, and this is plus 28. This is plus 7y. Why is it plus, Mr. Carlson? Negative times a negative gives you a positive. And then negative times 12 is a negative 12. All right, now I can start combining tons of stuff here. I can combine those on that side. I can combine these on this side. And I can combine these on this side. All right, so let's start going to town. So this is 38. Sorry, not 38. What am I doing? Awful. 36. 32 plus 4 is 36 minus 5y. This will equal. And then I have the 7y and then negative 17. So this is actually negative 9y. And then this right here, 28 minus 12, that's going to be plus, not 20. Wow, I'm awful with my adding today. 16. Should be 16. Good. All right, now I can start combining other stuff. I want to transfer this over to the other side. It doesn't matter what side you transfer it to. I'm just transferring over to that side. I'm going to transfer that over to here. So I'm going to finish my stuff up here in red. What do I have on the left side so far? Now, technically, I'm going to write it out, but I don't like writing it out. I will have negative 5y plus 9y because it's going to be transferred on the other side. I'm combining the like terms here, guys. And then I have 16 and then minus 36 because, again, it became a positive. I'm subtracting it over to the other side. These on the left side are going to become 4y. And this right here is going to be negative 16. Wow. That's 3 mistakes. I feel awful. You're probably thinking, like, who is this guy? Like, who is this math teacher of mine? 20. Man, divide by 4, and then that goes poofy. What am I left with? Y equals -5. And you're probably thinking also, all that work for just a measly 5? Yes. And of course, for good luck, I have my awesome unicorn here. Isn't it pretty? I think it's pretty. All right, pause it if you need to. Let's move on to the next one. Erase. All right, this one, I know it's kind of blurry, but it is an inequality, and all we want is interval notation. And then we want to graph the solution set on the number line. So this will be our first step. This will be our second step. Okay, but before we do any of that, we need to actually solve this beast. Okay, so let's distribute. This is 6x plus 1 greater than, man, that's like 4 right now. I feel awful. Maybe it's just really late. It is actually really late right now. Plus 3 and then minus x plus 6. Let's start combining on the right side because I can't do anything on the left right now. I can combine those. That becomes positive 5x. I can combine those, and that becomes plus 9. Let's transfer this over to that side, transfer this 1 over to the other side. So then this will become, and I'm going to just straight up go to the answer here, 6x minus 5x when it goes on that side is just x. And then minus 1 on the right side plus 9 will be 8. And the sign doesn't change. You know why? Because we did not, the inequality sign did not change because we did not divide by a negative or multiply by a negative. And since we didn't divide or multiply by a negative, that's my final answer. But hey, we still have a couple more things to do. So interval notation. Actually, usually what I like to do, and maybe you're this way as well, I like to personally get my number line first because that way it helps me with my interval notation. So I'm going to write my interval notation up here for step 1. And again, I actually like my, I'll abbreviate that notation. I like doing my graph first because then I can actually visually see, all right, what's happening here. So if you're like that, if you're about that life too, then by all means join me. 0 for reference, I have 8 because that's the number I'm interested in. This is not an equal to sign, so I'm just going to circle this. And which side is this arrow pointing to? It's pointing to the right side. So it's going to go boom, 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 all the way to infinity. So what does that tell us for our interval notation? Where does the graph start? Does it start over here? Does it start here at -1? No. Does it start at 0? Does it start at 5 right here in between 0 and 8? No. It starts where? At 8. Okay, so I'm going to write down 8. Is that parentheses or brackets? It is parentheses because it's not an equal to inequality. It is just a greater than. And where is it going to? Remember, our comma means going to. It's going to infinity. It's going to infinity and beyond. So that is my final answer. 8, comma, infinity. Now remember, infinity always, 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 always will have parentheses attached to it. Can you ever equal infinity? No. Okay, that's why it's always parentheses. Never brackets on infinity. I swear, if I see one of you on a homework quiz put down a bracket on an infinity sign, I'm going to lose my life. I mean, it's going to be really headache central. Inevitably, there will always be like 5 of you. I mean, I've been doing this for a while, so I know. And then 8. Why is it parentheses? Again, because it's not a closed dot here. This inequality sign, is it equal to? Your answer is no. Since it's not equal to, I'm going to put parentheses here. You may be asking, well, what if this was equal to? Would you put a bracket here? Yes, you would put a bracket here. And would that be closed as well, Mr. Carlson? Yes. Okay, so I'm going to recap that. If I have brackets, that means included or equal to. If I have parentheses, that means this is not included. Okay? Now, you can have, pay very close attention, you can have something that looks like this. This is just an example, a recap from the previous video. You can have something that looks like this, bracket 8, and then going to positive infinity in parentheses. And you're like, well, that's one bracket on that side, and that's another bracket on that side, but there's a bracket and a parentheses? Yes, this is just a general. If you're using brackets, included. If you're not using brackets and it's parentheses, not included. So that means 8 is included on this side. That's what we would say. It's included. Okay? But on this side, on the right side of the number line, it would be not included because you can't equal infinity, right, guys? This is just an example that has nothing to do with our actual bell work question here. It's just completely different. So don't try to get these confused. This is completely different right here. I hope that kind of maybe sums up some things with interval notation. If not, by all means, come to our Google Meet link. Don't take the homework quiz until you're really confident that you know what you're doing. And then once you know what you're doing, go ahead and take the homework quiz. Okay? All right, I'm going to erase. Let's go to the other ones. All right, I think this is actually our last one. All right, first thing, use notation, interval notation, and we graph the number line as well. Don't worry about that. It shouldn't be, we are actually doing the homework quiz. Don't worry. I forgot that, and I'm not going to stop the video just to solve it. Okay, we are still doing the homework quiz. It is still on. Okay, don't worry. Just because it's crossed off doesn't mean you don't have to do it. You still have to do it. Okay, let's solve this. This is an understood one going over here. So 5, just chilling, minus x minus 6, greater than or equal to 7 minus 9x. All right, we can combine some things over here on the left side. So this is negative x minus 1, greater than or equal to 7 minus 9x. All right, let's start making my x's go over here and my constants go on the other side. So what do I have? I will have 8x, again, if I minus, if I plus the 9x over here, negative x plus 9x gives me 8x, greater than or equal to. If I add the 1 over, 7 plus 1 is 8, divide by 8. Class, am I dividing by negative here? Your answer should say B. No. Okay, you're not dividing by negative or multiplying by negative, so you don't need to change the sign at all. This is my answer. Okay, x is greater than or equal to 1. All right, interval notation. I'm just going to abbreviate here. I'm not going to write down interval. I'm just going to do, what's my notation? I'm actually going to do it without drawing the graph. See if you can do it without drawing the graph. I'm going to just at least get preset here. So this is 0 and 1. Try not to do the graph. Try to just do the notation. Remember, it starts, where does a graph exist? Well, it always will exist right here where I start. So I'm going to start here. Is this equal to or not equal to? Class, you should say equal to, which means I would be using a bracket. And then since this is greater than 1, that means all of my solutions are 1 because it's equal to 1, right? So my solutions are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way to 100, all the way to a million, all the way to, where's the stop? Infinity. Can I equal infinity? No. This is my answer. Okay, that's my notation set. Let's see if it checks out with my graph here. Since this is greater than or equal to, I'm going to put a closed dot here. Sometimes on Math Excel, you'll see a kind of bracket. That's what we had here, right? Yeah, we had a bracket. And then since it's pointing towards that direction, I'm going to shade junkily, but I'm going to shade nonetheless all the way there. And positive infinity is all the way over here. Say hi, positive infinity. That's why we have that. Does our interval notation check out? It does. It does, it does, it does. All right, so that is the bell work. Go ahead and pause that video if you need extra time. All right, let's erase. That's the bell work. Now, homework quiz. First of all, science syllabus is due today, so if you have yet to fill out that acknowledgement form on the syllabus and on Google Classroom, have to do that. Do that now because I'll start putting grades in and you'll have a 0. Okay? Second thing, your homework quiz is going to be on Math Excel, of course. Okay, it's going to be on Math Excel. It's going to be 5 questions, 20 minutes. Of course, you can use open notes, obviously. You can even use my videos if you want. You don't have to use these videos, but you can't pause the homework quiz, so I'm just letting you know. You have 20 minutes. If you're in class, you would also have 20 minutes, okay? I am testing you on literally how well you did the homework, but also how well you just understood the material. Okay? The general rule of thumb, and I will stress this until the end of the class, until you go all the way through your math high school career with me. When you take a homework quiz with me, the reason why I do the homework quiz is because it tests you on the homework. Okay? That's what the purpose of it is for. It's literally a small grade, but it still tests you on the homework. If you don't do the homework, you will more than likely do bad on this homework quiz. So I strongly encourage you to complete the homework as much as possible, as much as you feel comfortable with doing, as much as you could possibly do before you actually take the homework quiz. Okay? Again, if you don't do the homework, you're going to have a gnarly time doing the homework quiz. Right? If you do the homework out at 100%, how much extra credit do you get on this homework quiz? Should be 2 extra credit points. Okay? So if you don't want to take the homework quiz before you've finished this homework, that's perfectly fine. Finish this homework assignment first on Math Excel, then go to the homework quiz. And if you completed the homework assignment at 100%, you can get up to 2 extra credit points. Sweet. All right. Third thing, actually, that I want to tell you, when finished, I want you to review your answers. Please review your answers. This is super important, guys. Review your answers. And then here's the important part. I'm going to underline it. Ready? You're watching? Send any partial credit requests. What does that mean? What are partial credit requests? Partial credit requests are literally requests that are sent to me via email asking for partial credit. So for instance, if you had on one particular example, what if you said, y equals 8, but Math Excel actually wanted x equals 8. You just somehow messed up. You accidentally put the wrong variable. And Math Excel wants this, but this is what you got. Guess what Math Excel is going to make sure is wrong? Your answer. It's going to mark you wrong. The problem with that is you technically got the right answer. You just did a silly mistake, right? So what you can do is you can send me via email saying, hey, on this homework quiz, on question, I don't know, just 1, for instance, you can say, that happened to me. Can I get partial credit? You can get more than partial credit on that. I can give you the whole problem. Okay, but if you just let it go and you don't email me, a lot of you may be missing some good cheddar cheese points, I'm telling you. Okay? So please, if anything, just email me saying, hey, can you just check this? If you don't send me an email to check your homework quiz, I am not going to open it. Okay? I'm just going to see the grade that you got, that Math Excel assigned to you, and I'm going to put that in Synergy. I'm going to put that in the gradebook. But if you made a silly mistake like that, or let's just say you put parentheses and you said 8 going to infinity, but really it was bracket 8 going to infinity. So really, it wanted this answer, but you put that answer. Guess what? It will actually mark you wrong. But if you send me a partial credit, I can actually go in there and give you some credit. I'm not going to give you the full credit. I think I belabored the point between the brackets and the parentheses hard enough. So if you don't understand the brackets or parentheses, just rewind and keep going back over the videos. But I can still give you some partial credit requests. Okay, I can still give you maybe like 3/4 of the points instead of the full point. Whereas Math Excel will give you 0 points. You see how it may benefit you to communicate to me? So please review your answers after you are done with the homework quiz, and then see if there's any of those slight errors that you can just send my way, and then I will go and review them. Now, I'm the sole judge, so that means, if you send me something, that doesn't mean you will get it. That does not mean you will actually get the point back. Okay, I can still reject that point, and most of the time I won't email you back, by the way. You'll just have to see on Synergy if I actually gave you the point or not. And if I did not give you the point, if you want to challenge it, that's fine, but I'm probably just not going to pay attention to you because, again, I'm the sole judge. Math Excel rarely makes mistakes. So if you feel like Math Excel was unkind to you, just let me know. If you're like, I don't know why I got this wrong, I will just send the question my way. I will look at it, absolutely. And if I feel like it was unfair or if something happened, then I'll give you the credit as needed. But again, if you don't send me the email, I'm not going to look it up. All right, I belabored that point enough. Go ahead, pause the video, go to town on that homework quiz. If you're already done with the homework quiz, let's get started. You should begin your Cornell notes, absolute value equations and inequalities. This is the second and last lesson, video lesson that we'll go through. I will still have videos for the other things like the Desmos activity and such and the actual quiz, but this is the actual last lesson that I will go through with actual instruction with me teaching and everything. All right, let's get started. So don't forget, honors contract is due Friday. Send your email to me from a parent or guardian saying, yes, my child is participating in honors. So I can solve and graph absolute value equations and inequalities by collaborative review. So we are doing review here. It's not going to be collaborative, unfortunately, because, you know, COVID. But you don't need to write down the objective. All you need to do is write down the essential question, the one with the question mark. That's italicized. Write that down in your notes. I'm going to be checking for that on Friday. All right, let's get started. Pause the video if you need to. What is absolute value? Let's just remember what absolute value is. Can we remember that? Absolute value is literally the distance in positive integers a number is from 0. So 0, the origin on a number line. That's what absolute value is. So for example, if I have the absolute value of 4, it is 4. Why is that? Because if I put down on a number line here, this really junky number line, this is 0. And if I have 4 here, this is 3, 2, and 1. How many units is 4 from the 0? Okay, how many units is 4 from 0 on the number line? It's 1. Whoa, that was awful. Oh, that was really bad. 1, 2, 3, 4. So this is 4 units. Perfect. So that is my answer 4. What if I have negative 4? What's the absolute value of negative 4? Remember, we use those vertical bars to signify it. Well, again, if I had negative 4 over here, this is negative 3, negative 2, negative 1. How many units is negative 4 from 0 on the number line? So this is 1, 2, 3, 4. So it's also 4 units, which is exactly why we got 4 right here and 4 right here. So basically, whenever there's a negative inside, it doesn't matter. Just make it a positive. Nah, seriously, I want you to understand that it's distance. It is distance. All right, let's move on. Let's erase. So I hope most of you remember that. Let's go through equations. Okay, what are absolute value equations? So if I have the absolute value of x, guys, think about it like this. If I have the absolute value of x, okay? If I have the absolute value of x, and that equals 10. All right, so in general, this is what it means. Okay, so again, write this down. If I have the absolute value of u, just one random variable, equals c, in this case, this will be like a constant. So constants, remember numbers are constants. So this is basically the same thing as saying 10. Okay, if I have it like that, this then becomes u equals c for my first equation, and then my second equation will become u equals negative c. I need to include both. What does that mean? Okay, this step allows you to solve the absolute value equation by eliminating the absolute value signs, which we need to do. Notice how there's no absolute value signs. Come on. Notice how there's no absolute value signs right here. They're completely eliminated by solving for each of the possible solution sets. Remember, for absolute values, you can have a negative or positive, which means how many solution sets could you technically have? 2. Dos. Okay? Which means we're going to have 2 equations here. 2 equations. That's vitally important. Whenever I go through this, students just do not jive well with that. 2 equations. I need 2 equations here. All right? So let's erase this. Let's go to town on my first example. Here are the steps. You should definitely write down the steps. Please write down the steps. You need to. Okay, they're vitally important for you. Example 1, isolate the absolute value part. So those are the bars, the field goals. Set up the 2 equations as shown. But I'm going to show you a different way. So if I have this equals c, then I have this. Notice how there's no negative here, but this does have a negative here. So this will be my first equation, and this is my second equation. Perfect. Solve both equations, and then I'm going to check both solutions. Now, you don't technically need to check both solutions. Let me just rephrase that. You don't technically need to check both solutions, okay? That's just kind of a user error. So this is my first equation, my absolute value equation. This is a question that you'll literally see on Math Excel on your homework quiz for the next day. And you'll also see it on the quiz review and the quiz, and you'll also see it on the homework. Yeah, so you'll see something like this, which is why I'm going through it. Let's get a night like sky blue. You feeling sky blue? Maybe not. All right. First step, I want to isolate. Oh, that's pretty. I like that. Isolate the absolute value part. What does that mean? Well, first of all, look at this. Is this the bars? Are they completely and utterly by itself on one side of the equation? Yes or no? Your answer should be no. Because there's a 7 that's not inside the absolute value part, that's attached to it. How is it attached to it? This is technically multiplication here. It doesn't show you that dot, but I'm going to put a dot there because that dot means multiply. So that means I need to first do the opposite of multiplication, which is division. And what I do to one side, I must do to the other, which means that goes poofy. What am I left with now? The absolute value of 2x minus 5 equals 35 divided by 7 is 5. Perfect. Perfect. All right. Now, is it isolated? Yes. Okay, the absolute value part is isolated on one side of the equation. I can now go to the step 2 and start setting up two different equations. My first equation here is going to be everything I see in the absolute value bars, except I don't write the absolute value bars. Okay, and then equals 5. So it's literally the first equation is literally the exact same thing I see it, just 2x minus 5 equals 5, but I just don't write the absolute value bars. That's the easiest one. Okay, my second equation is literally everything that I see here, everything that I see, except for the fact, ding, 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 I have a negative there. So I have a negative attached on that negative 5. I'm following that pattern right there, guys. See this negative right there? Okay, so in the first equation, it's exactly how you see it, except for the fact there's no absolute value bars. The second equation is exactly how you see it, except for the fact it doesn't have any absolute value bars. And also, except for the fact that it has a new negative attached to it. That's how you follow it. Okay? Now, what is step 3? Solve both equations. Let's solve both equations now. I can add the 5 over, so this is 2x equals 10, and then this is x equals 5. That's my first answer. Yay, smiley face. What's my second answer? I can add the 5 over. So if I add the 5 over, that actually gets 0 because these go poofy, negative and a negative 5 on either side of the equation. They balance each other out, so they go poofy. But that's okay. You're thinking like, oh my gosh, what's going to happen? It doesn't matter. You can still divide by 2. And if I divide by 2, what's 0 divided by 2? It is 0. That's my other answer, smiley face. Okay. Now, I will show you the check just because I think it's still good to know. So what's the check? That's my check. Okay, what is it? All right. What it means is if I plug 7 in, or sorry, if I have 7 and the absolute value of 2, if I plug in my answers that I got, it should check out. It should ring true. So if I plug in 5 here, and then minus 5, absolute value equals 35. Remember, I'm plugging in 5 for x because that's what I found. Okay, so this is 7, absolute value. This is 10 minus 5, absolute value equals 35. What is the absolute value of 5 here? You guys will say? Well, the absolute value of 5 is 5. Notice I'm using parentheses now instead of absolute values. So the absolute value of 5 is 5, but still multiply together. So what is 7 times 5? Well, of course, it's 35. Does each side of the equation check out? It does. That's what I mean by checking out. Now, what if I plug in 0 here? If I plug in 0 for x, what's 2 times 0? It's 0, so that just goes poofy. So then I'm literally left with 7, and the absolute value of negative 5 equals 35. By now, you should see what's the absolute value of negative 5, guys? 5. So what's 7 times 5? It's 35. Will that check out with the right side of the equation? It will. Okay, so that's how you check it out. I'm not going to do that ever again. I may do it when it comes down to inequalities, but I'm not going to do it really for equations. So let's go through a couple more examples. Pause anytime when you need to catch up, okay? Same thing, but now it's a little bit more like, all right, it's a little bit more scary, but it shouldn't freak us out too much. And the reason being is because we have steps. I've given you steps here so that you can solve them. So isolate the absolute value part. We have a couple of things we need to do. First of all, the 3 is multiplied by this, so I need to get rid of that. But I also have this. So, again, think about this. You could technically divide by 3. But if you divide by 3, you have to divide by 3 here as well. And here, and here. So that goes poofy, yes, but then what if you don't have a number like 12 that's divisible by 3? What if this was 17? You just made yourself a fraction. Do you really, really want that? No, you don't want that. So the easier thing to do is always, always, always look at this number and then subtract that first. So what do I have now? So I have 3, the absolute value, because we're still on the first step. 7 minus 5 all over 2x. And this equals 12 minus 12 is just 0. And then 36 minus 12 is 24. Now what we can do is divide by 3 to both sides. That goes poofy. So what am I left with? I'm left with the absolute value. Make sure you write down the absolute value. That's important. Absolute value of 7 minus 5 over 2x. And then this equals 24 divided by 3 is 8. All right. Now, is it isolated? Yes, it is. So yay, we can check mark and we can start writing our 2 equations. What's my first equation? My first equation is literally exactly how I see it, except for the fact it does not have absolute value bars. Okay? What's my second equation? My second equation is exactly how I see it, except for the fact it doesn't have absolute value bars, but it also, let me put an X here, sorry, it also has a negative. Okay? Hope that's clear. Now, I'm going to start doing the work up here, probably up here, okay? So I'm going to do the first equation. So try to follow along with me. I'm going to kind of bring that all the way up here. Is that okay? I hope it is. So first thing I need to do is actually subtract the 7 over. So if I subtract the 7 over, what will I get? I will get negative 5 all over 2x equals 1. Now what do I do? Well, you see here, I have to multiply by the reciprocal. Why do I have to multiply by the reciprocal? Because this is a fraction. So I need to multiply both sides by negative 2 all over 5. And what I do to one side, I'm going to kind of squeeze it in here. Negative 2 all over 5. I'm going to multiply it. So the 2's go poofy, the 5's go poofy, which means I have x. What happens here? What's 1 times anything? Itself. So what's my answer? Negative 2 all over 5. That's my first answer. Perfect. Let's get to my second answer. Let's actually switch back to sky blue. All right, my second answer. Same thing, I'm going to subtract the 7 over. So I have negative 5 all over 2x, and then equals, if I subtract the 7 over, I have actually a different number. I have negative 15. I still need to multiply by the reciprocal, though, guys. So the reciprocal is negative 2 all over 5. What I do to one side, I must do to the other. So I'm going to kind of fit it in here. The 2's go poofy, the negatives go poofy, the 5's go poofy. I'm left with x equals. Now what happens here? This is technically all over 1, right? Right? It's technically all over 1. And then I can actually divide into this because that is cross division, cross multiplication. So I can divide. 5 divided by 5 is 1. 15, though, divided by 5, the exact same number, is 3. So now what I have is negative 3 times negative 2. And technically all of this is divided by 1, but that's 1. We never really write it, so I'm not going to write that. So what's my actual answer? 6. Boom. Perfect. All right, we're just going to town on this. All right, so that's equations. We're now going to go to inequalities. So So equations are actually very straightforward. Make sure you isolate the absolute value part and so forth. And then get your two equations that look something like this. Make sure you know that. Make sure you know that. Okay, you can use the notes on the homework quiz, guys. Use your notes. Now for inequalities, there's actually two sets of inequalities, of course. So when we do absolute value inequalities, I need to make sure I know the less than, and I also need to know the greater than. So less than sign. It's actually less than, okay? This is the less than sign. So I'm going to do those first. So less than sign. Solving the absolute value inequalities are similar to solving equations. However, it depends on the sign of the inequality. So since it depends on the sign of the inequality, however it flips, I'm going to first teach you how to do less than signs because it has its own kind of unique formula. And then I'm going to show you how to do greater than signs. All right? So less than sign or less than or equal to means what we call and. It's what we call a compound inequality. What does that mean? It means it will look something like this. In general, if I have the absolute value of x less than or equal to some number, c, it will then pop out to be this, where I have a negative on this side and a positive on that side, where x is in the middle. I can also split it up to look something like this, okay? Where I can take this side, and that equals this junk right here. Notice how I'm kind of flipping that as a pancake. So I'm taking the x, flipping it over, taking the sign, flipping it over. So now kind of flip signs here. But the negative c just flips over, but still a negative c. And then I'm also taking this side and doing it that way. So you're basically taking two separate inequalities and combining it into one. If that made no sense to you whatsoever, if you're like, holy junk, that didn't make any sense to me at all, just remember, I got your back. You have to believe that. Okay, I'm here for your success. The only one you need to worry about is that, the middle one. It's the easiest one by far. The only reason, though, I do it this way is because it helps you see a little bit deeper into the inequalities and why we call them inequalities and what they really are. Okay, so this is going to be our main formula. Let's continue on. So here are the steps. Make sure you write down the steps. First and foremost, obviously, you have to isolate the absolute value part. Second step, set up a compound inequality based on the inequality symbol. So in this case, it's less than. So we're doing less than signs. So solve the compound inequality, of course. We're going to graph the compound inequality with the number line, and then we're going to write it in interval notation. So you have a lot of steps here. Because Math Excel is going to ask you for all of it. I'm going to start out really nice and sweet. Isn't that great? Nice and sweet. So first things first, isolate the absolute value part. Is the absolute value part completely and utterly by itself on one side of the inequality? You should say yes. Okay, it's on the left side. Nothing else is attached to it. Nothing's multiplied by it. Nothing's added to it. Completely by itself. Yay. That checks off. Now, step two, we want to take this and put it, so this is step one. Step two, we want to take this and put it into an inequality. Remember, it should look something like this, negative c, and then some expression u, and then c. So it should look something like that. So what does that mean? It will be negative 6 less than, and then whatever is inside the actual absolute value part gets dropped down, and then I finish it out. So that's what the compound inequality should look like. I hope that's pretty clear. Okay, I just basically put 6s on both sides, put whatever is in the absolute value part in the middle, and then I tag on a negative. Do I tag on the negative over here on the right? No. Remember, you're reading it left to right. Mathematicians read math left to right, just like English people do. We read math left to right, right? So that means we are going to put the negative on the left side because it is left to right, and negatives are on the left on the number line. How do I solve this? How do I solve this? Great question. First thing, I'm going to isolate I'm going to solve, this is step 3 now, I'm going to solve the compound inequality. Excuse me. So I can add 8 to all sides now. That goes poofy. So what's negative 6 plus 8? That's 2. And then I keep the sign the same way. And then this is x. And then what's 6 plus 8? Well, 6 plus 8 is 14. So what this tells us is this is now my answer. Not too bad, right? Not too bad. Not too bad at all. I really like them. All right. Now, step 4. Let's keep it in red. I really like red. It's my favorite color. Let's graph the inequality. Really junky graph here. What this means is I'm going to actually put 2 and 14 in here, and I'm probably just going to put like 10 here for reference. So this is my number line here. Now, since these are less than signs, I'm not going to close them. I'm going to open the dots. They're open dots. And what this tells us is literally all your stuff. I'll do an open dot here. Very Valentine's Day. What it tells us is that all of my solutions are in between 2 and 14. So I'll even write it out. This tells us that my solutions are equals in between 2 and 14. That's what that is saying. Okay? My solutions are in between 2 and 14. That's why x is in between. Any number in between 2 and 14 where you're not including 2 and 14, that will actually make this equation true. Let's go to step 5. What's my interval notation? Well, where does the shading start, guys? The shading starts at 2, so I'm going to write 2. Where does it go to? Where does it stop? Well, it stops at 14. Am I going to do bracket here? Well, yes, you have to ask yourself one important question. Are you ready? Is this an equal to sign right here? No, there's no equal to sign here. So that means I need to do parentheses, parentheses. Is this an ordered pair? No, it's not an ordered pair. This is a notation set. Okay, I'll abbreviate, just note, not. Okay, I'll put a period here for notation. This is a notation. It's not a relation like ordered pairs are. If ordered pairs are relations, this is a notation. Okay, so you'll literally type that into Math Excel. 2, 14 with parentheses. Notice how to 2 comes before 14 on the number line? Because you read math left to right. Okay, so since you read math left to right, the 2 comes before the 14. All right, let's go to town. Let's do a couple more for less than, and then we're going to go and do greater than. So I'll do actually, let's just do one more. Same exact steps. All right, let's hit it. Whoops. Let's do green here. All right, is it isolated? No, it's not isolated. I need to subtract the 6 over. So I'm going to just do my first step over here. Subtract the 6 over, so that means I have 4x, 2 minus, and then this is going to be less than or equal to 17, and then minus 6. That's what it should look like. I want to subtract that over here. All right, so what will this be? Absolute value of 4x minus 2 less than or equal to 11. Now, is it by itself? Yes, check mark. Let's set up step 2, the inequality, compound inequality. I'm going to have negative 11 over here. Keep the sign. This is going to be whatever is inside the absolute value part. I'm going to keep that. And then the sign again, and then positive 11. Now, notice a couple things. First of all, I dropped the absolute values because you're supposed to. Okay, you're supposed to drop the absolute values. So you should not have any absolute values after step 2 here. Okay, that's what it is. Also notice how the negative comes before, left or right, the negative comes before the positive 11. Okay, the negative 11 comes before the positive 11. And third, I kept the same sign all the way through, the same inequality sign. All right, let's solve this beast. I'm going to add 2 on both sides. So if I add 2 on literally every single side, I have negative 9. If I add 2, because I want to get rid of that 2, right? I'll have 4x I want to put add to, just in case, some students are not really understanding. I'm going to add 2 here. And then 4x, that goes poofy. 11 plus 2 is 13. Now I'm going to divide by 4, divide by 4, divide by 4. What's my actual answer? Let's put it up here. This will be negative 9 all over 4. And then this is less than or equal to x, because the 4's go poofy. And then this is going to be 13 all over 4. Great. This is my awesome inequality. Okay. Now let's do the graph. What does the graph look like? Well, the graph is going to look something like this. The negative 9 all over 4 goes first. I'm going to put 0 in between for reference because there's negative and a positive, so I know 0 is in between there somewhere. This is 4. What will this look like? Glad you asked, class. Well, since it's equal to, it's definitely going to be closed. It's also going to be closed on this side as well. And this says that all my values are in between these two values. All my values of x are in between negative 9 over 4 and 13 over 4, which means that's what my graph should look like. I'm actually just going to keep it right. Same thing. So what's my interval look like? What does my interval notation look like? Perfect. What will that look like? Well, where does the graph start, guys? It starts at negative 9 all the way to 4, or divided by 4, and it goes all the way to 13 all over 4. Brackets or parentheses? I hope I'm hearing you say brackets. I'm going to use brackets on all of them, both sides, because it is closed dot on both sides. So if you got that right, give yourself a big smiley face. All right? That's my last less than. I'm going to go to greater than, and then we will be done. Isn't that great? Awesome. Awesome sauce. Greater than. So greater than means or. Okay, greater than means or. So it's not and, like two things combined and together, like the less than sign. Okay, the greater than sign will actually mean a compound inequality, just like before, but it means or. So what will this look like? What will our new quasi-formula be? Well, in general, if I have absolute value of x where it's isolated and on the left side here, and it looks exactly like this, and it's greater than c, some random number, I can make it look like this, where I have x, change the sign right here, x, change this inequality sign, and put a negative on it with the same c. And then my second equation, I have it exactly how I see it, except for the fact, that's my first equation, except for the fact I don't have the absolute value bar. So this one is a little bit more complicated, and I hope you guys see that. It is a little bit more complicated, as it should be. It's just a little bit more intense, okay? But that's okay. We're gonna go through it. Don't worry. So I'm going to erase this. Make sure you memorize. Well, don't memorize it. Just make sure you know it. Same steps as before. Nothing changes. Let's go to town. All right. What do I have here? First of all, it's not isolated because this 1. So I need to move the 1 over to the other side. This is my first step. So I have the absolute value of 4x minus 4. And then greater than, notice the sign, greater than, I minus the 1 over, so that means it is 8. Now that it is isolated, my absolute value part, not the x itself, but the absolute value part, this whole section is by itself, I now can jump to step 2. What is step 2? Set up the compound inequality based on the inequality symbol. Well, we are using greater than signs. So again, I'll kind of write down the formula here. It should look something like this, where I have, x is greater than, what the junk is happening here? Being sidetracked. I have the same thing, so my first equation can be the exact same thing, 4x minus 4. Okay? And then I'm just going to drop the absolute value bars and then do the exact same thing I see, greater than 8. That's my first equation. My second equation is, of course, 4x minus 4. But I'm going to change two things here. And the two things I'm going to change are the sign, and then I'm going to tag on a negative. So those are the two things that I change. What's in pink here. I'm going to change the sign to a less than sign, and I'm tag on a negative. All right, now we just solve, like step 3. That's the hardest part, guys. If you can get that, you're solid, because now it's just solving regular inequalities. So I add the 4 over, this is 4x. I add the 4 over, so that's going to be 12. I divide by 4, and I get 3. So that's my first one. In this one, I add the 4 over, so this is 4x. Add the 4 over, so that's going to be negative 4. I divide by 4, so this is going to be negative 1. Am I dividing by a negative here? No, I'm not. Okay, now this is technically or. So now my solution sets could be this or that. So let's go ahead and put them on a number line. What will these look like? Okay, what will these look like? First of all, I have negative 1. I have 0 for reference, and then I have 3. Let's do that. All right. Now, negative 1 comes first on the number line, so let's do that one first. Now, is it equal to or not equal to? It's not equal to. It's just less than. So I'm going to do open dot. And where is it pointing? It's pointing to that side. This side. It's pointing that side. So that means it's pointing to the left. So that means it's going to go shade like that. Now, the 3 here, it's not equal to as well, so I'm going to do that. And it's also pointing in a direction, but it's not pointing in the same direction. It's pointing actually in the right, in the direction of the right. So it's going to look like that. So notice how before in the examples we had, they were kind of meshed together. Like we would shade in between for the less than signs. But now for the greater than signs, we actually have them separated here. That's why it means or. So it doesn't mean and combining them together. It means this or that. So that means when we write it in interval notation, guys, this is going to be a lot harder. So I need you guys to pay attention. Are you ready? So I'm going to do 5 here. My interval notation is going to look really, really funky, and I need you guys to pay attention. So what will this look like? Well, first, where does the graph start to exist from left to right? It starts to exist all the way over here. What's all the way over there? Well, all the way over there is, of course, negative infinity. So I'm going to write negative infinity here. Where does it go to? Well, negative infinity, if I'm trailing on a number line, because this is all the way over here, negative infinity. Just imagine the number line is going for forever. It goes. Where does it stop? It stops right at negative 1. Now, is that going to be a bracket or parentheses? You best be saying parentheses. It's not closed. Now, here's the question, and here's the important part, and here's why it's different, okay? Why it's different. How can I get from negative 1 all the way to 3? That's the question, right? Here's how you do it. It's called a union, a U. It's called a union of sets. This is technically a set of numbers. That's a set of numbers. Remember set builder notation? Okay, it's a set of numbers, so I'm going to actually write union, and then now it kind of jumps, time hops to my number 3. So then now I can do parentheses 3. It's parentheses because it's not included. And where does this go? Well, it goes all the way to positive infinity, of course. So positive infinity. And I can never, ever, ever, ever have brackets on infinity. Why is that, Mr. Carlson? Can you count to infinity? Oh, shoot, I can't, Mr. Carlson. That's why. So you can only have parentheses on the infinities. And that is my answer for my domain interval notation. Awesome. This is great. So replay that if you need to. I'm obviously going to go through more examples of this. Let's just move on. This one's a little bit more complicated. But don't worry, it's not going to be as complicated. Okay, don't worry, it's not going to be as complicated. But let's go through it. First things first, is it isolated? It actually is. It's only by itself. Second things second, okay, I need to, and I'm going to actually do it up here, set it up depending on the inequality symbol. Well, the inequality symbol is greater than, so that means I'm going to do the first equation exactly how I see it, literally the exact same thing. Nothing's changing except for the fact it doesn't have an inequality, or sorry, it doesn't have an absolute value on there. All right, second equation. What is it? Well, it's going to be the same middle. Whatever's inside the absolute value bars, it's going to be the same thing. But what does change is this. It's going to change the inequality sign, and then it's going to tag on a negative to my constant. Okay, so it's going to look something like that. Let's solve both of them. So how do I solve this? Well, I have to multiply by 5 to both sides first, so that goes poofy. So I'm left with 4x plus 2 greater than or equal to, this is 25, minus 2, so this is minus 2, so this is 23. I divide by 4. Why is it 5? Oh, shoot. I hope you guys caught that. If you caught that, I was like looking at my notes and like, oh man, that's totally different. This is 2 here. I'm still going to multiply by 2 though. So this should not be 25, that should not be 23, this should be 10. Good thing I caught that. So that should be 10, and this should also be 10. Divide, not 10, dang. When I subtract the 2 over, what do I get, class? I should get 8. Okay? It's okay, math and teachers make mistakes too. I make mistakes. It's been late, just chilling. This is divided by, and then that goes poofy. So x doesn't equal, again, another mistake. I'm not thinking. And this is greater than or equal to 2. Awesome. I'm almost confident that's correct. Okay. Now let's do the same thing. Times by 2, times by 2. So that goes poofy. I'm left with 4x plus 2 less than or equal to. I didn't do the equal to sign. Another mistake. Algebra is not my strong suit, I guess. Negative 5 times 2 is negative 10. I can subtract the 2, subtract the 2, that goes poofy. This is 4x is less than or equal to, what's negative 10 minus 2? That's going to be negative 12. So this is 4 divided by 4, and then I get x is less than or equal to negative 3. So I get these two inequalities. Remember, they're or. The or, I can have this or that. Now let's do our third step. Our third step was that, so great. Let's do our fourth step. Graph. What is graph? Our fourth step. What does that look like? Well, you see, kids, it'll look like this. A junky graph. Negative 3, 0 for reference, and then 2. So I'm just kind of doing that. Let's do green. All right, negative 3. Is it closed? Yes, because it's equal to. And is negative 2 closed? Yes, it's equal to. Again, sometimes you'll see brackets. Which side does 2 go to? It'll go like that. It points in that direction. And what side does that go to? It points in that direction. Okay? Sometimes you'll see brackets here. And so when we go to step 5, our interval notation, left to right, where do I start? Well, I start at negative infinity. Where does it stop? It stops at negative 3. Brackets, because that's a bracket here. How do I jump from here to here? I'm glad you asked. Remember, a union, brackets, and this is 2. Where does it stop? It stops at infinity. Notice I'm reading left to right. I'm reading left to right. That is my interval notation for step 5. Perfect. Awesome. I know we blasted through that one, but that's okay. Okay, let's erase. I think I have one more. I don't. Great. Awesome. So I don't have any more left. So go back, review this video if you need to. Here are the summary points. We evaluated algebraic expressions. We solved absolute value equations in one variable, including fractions. We looked at absolute values and how to express distance. And then we also looked at inequality symbols. We found the domain of each equation by evaluating interval notation and set notation and so forth. So awesome. Now, since you're done with this lesson, you can definitely go and complete the homework quiz if you would like. Make sure you do the homework quiz as much as possible before maybe Thursday. If you do the homework quiz before Thursday, then I think you're in good grounding. If you're doing all these quizzes on like Friday, the last day, then that's a little headache for you. But if you want to wait to do bell work, that's definitely cool too. So if you want to wait until the next video, just watch the next video. I do bell work, kind of reviewing everything for the absolute value equations, and they will have homework quiz questions on there, similar questions like that. So I can do that for you. So go ahead, go to the next video after you complete the homework assignments, and then review the bell work. And then right after the bell work, we'll get into the homework quiz. All right. Remember, if you complete this homework assignment as 100% on Math Excel before you take the homework quiz, 2 extra credit points. Until next time, Algebra 2.1, it's been real. I'll catch you later. See ya.